Well, hopefully we didn't have too much trouble when we were working in our part modeling exercises. Now that we've done a little light lifting, we're going to get into another phase of working with the Inventor test drive. And this takes us into working with the assembly environment inside of Autodesk Inventor. This portion will be broken up into 3 parts. Part 1 is going to consist of one of the mainstays when working inside of our assembly environment. And that's really, how are we going to build our relationships between our parts so they're positioned correctly inside of an assembly file. We'll call this using our constraints. So we're going to be able to go through, place, and constrain our components in an assembly file. We're also going to take a look at adding other work features into our assembly files themselves. In this case, we'll be working with work planes themselves. This is going to help us set up our relationships in most cases. We're also going to take a look at working with sub-assemblies within an assembly file, placing them and utilizing them. And, of course, one of the most important things of when working with 3D is using parameters inside of our designs. Being able to go through and build those relationships with our parameters to make simple and effective changes. Once again, let me hand this over to my partner in crime.
Now with this exercise, we're going to work with our lift assembly and constrain the claw that we've created in a previous exercise and some additional parts. I'll rotate my assembly around, and we're going to be inserting and constraining our claw, this lift ring, and then also this bracket right here, this pivot plate right here. So let's first start off by opening up our lift assembly. So I'm going to go browse and open up the lift assembly. And now I'm ready to place components. So I'm first going to place our claw that we created. And I'm going to pick up an insertion point right there. If I wanted to add multiple claws, so more than one, I could keep on inserting. But I only need one for this exercise, so I'm going to right click and select Done. I'm also going to place my lift ring, and I'm going to place one instance of that up here, and then select Done to get out of my Place Component command. Now with my components placed, I can now start constraining them to my lift assembly. First off, we'll constrain our claw to the assembly. The Constrain tool is located on your Assemble tab under the Positioning, and I'm going to click Constrain. First constraint I will do is the Mate constraint. I'm going to mate first off this inside face here, and I want to mate that to the opposite of this face here. So I'm going to hover over that inside face and wait for my selection tool to appear, and then I'll click the arrowhead, the right arrow, to toggle over to the next plane. That's the plane that I want to make mate to this one here, so I'll accept that one. So right arrow and then select the green selection tool, and then it will give you a preview of that constraint, and then if you approve of that, you can hit apply to accept that constraint, and then you can apply additional constraints all in the same command. I'm done with this for now, so I'm going to hit cancel because I want to drag my component outside right here and then get ready for the next constraint. Next constraint is I want this hole to constrain to the hole on my assembly. So I'm going to go back to my constraint tool, and with the mate constraint I'm going to select the inside surface of that hole along with the inside surface of the assembly hole, and then accept that. I can click and drag to see what else needs to be constrained. As you can see, it is constrained to the pivot, to those two holes. Next is I want to constrain this using an angular value. There is no flat surfaces really to do that, so I'm going to need to establish a work plane on my assembly so I can constrain via an angular constraint. So I'll switch over to my Model tab and place a work plane. I'm going to use the Origin folder for my assembly, And I'm first going to select the YZ plane because I want to go on a 30-degree angle off of that YZ plane. But it needs to pivot along the Z-axis. So my two selections for this work plane will be YZ plane and the Z-axis. Once I select on the axis, it'll give me the angle dialog where I can plug in my angular override. Taking note that I have a preview of the orientation of my work plane. This is correct, so I'm going to accept that. And now my work plane is created. So now I can go back into my constraint tool, and I'm going to switch over to an angular constraint. But this time, because I'm doing an angular constraint, it's always good practice to turn on your predict offset just so you can see what angle it is currently, and then you can override it. So my first selection, I'll select the work plane. Second selection will be the back face with the emboss on the claw. And it puts that value of that angle in my dialog. The angle that I want my part to be is 30 degrees, so let's override that with a 30-degree angle. And then click OK. Now my claw is fully constrained. I know this because I cannot click and drag it, and also when I click on the part and try moving it, I get that little symbol next to my arrowhead letting me know this cannot be moved. It is now fully constrained. I'm now done with my work plane, so just to clear up my display, I'm going to turn the visibility of it off. Next, I'm going to constrain my lift ring to the assembly, and for this I'm going to use the Insert constraint tool. Let's be sure first that we turn off our predict offset. There we go. Now we're back into the insert. And I'm going to select, with the insert constraint, my circular edge of the tapped hole on my assembly. And then I'm going to select the circular edge on my lift ring. So that edge right there. That will constrain those two together along those two edges, and line up the axes too. So now if I click and move on my lift ring, you can see it is fully constrained and is actually interacting with my assembly now. Next I want to control the movement of my lift assembly. So let's rotate our assembly so we can see the bottom. And for this constraint, I want to make flush this face along with my bottom of my assembly, so this face right here, but I want to apply an offset because I want the distance between the two to be 57 millimeters. So I'm going to add a make constraint, but this time I'm going to switch my solution over to flush, and then select the bottom of the lift assembly and bottom of that part right there, and then add in my offset of 57 millimeters. And now you can see this is fully constrained, and it's going to be locked in at 57 millimeters from my face here to the bottom of the assembly. Let's switch back to our home view. Next I need to add another component, and I'm going to add our pivot component and place it roughly right here. Now this needs to be constrained to my lift assembly. So I will constrain this with the insert constraint again and select the inside circular reference there and the circular reference on my assembly. Cancel out of that, and you can see it can now pivot along there. And then last but not least, I need to constrain my pivot component with my lift assembly right here. So let's just do a make constraint, line up the axis of my pivot part to my assembly, apply the changes, and now you can see this is fully constrained. Let's now save the file so we can use it in a future exercise.